So for our next learning target, we need to remind ourselves of the law of exponents. And you might have seen the law of exponents last year in math class or maybe in middle school, but in case you don't remember, we're going to do a little refresher of those rules. So the first rule that we're going to look at is, what if we had a to the b times a to the c? And we have a shortcut for when we multiply with the same base. And let's plug in numbers to see what that shortcut is. So let's say for A I plug in 4, for B I plug in 3, and for C I plug in 2. So Miss Solomon's here, she's going to act as our student. And Miss Solomon, is there another way for us to rewrite 4 cubed?
Yes, 4 times 4 times 4.
Okay, and I'm going to bring down that multiplication sign. And another way for us to write 4 squared?
4 times 4.
So what are you seeing in this line here?
It's the same as 4 to the 5th power.
Same as 4 to the 5th power, because just like she said before, exponents represent repeated multiplication. We have 4 multiplied by itself 5 times. So if we now know the answer to 4 cubed times 4 squared is 4 to the 5th, are you recognizing a shortcut?
Yes, we can keep the base the same and just add the exponents.
Keep the base the same and add the exponents, because we know that 3 plus 2 gives us 5. So our next law of exponents that you might have seen before is when we divide with the same base. And since we just did multiplying with the same base and you saw that we add the exponents, you might be able to infer or come up with it on your own what you think might happen when we divide with the same base. But let's do what we did before and plug in some numbers so that we know exactly why it's happening. So let's say we have 4 to the 3rd divided by 4 squared. And just like Miss Solomon told us before, another way to write 4 cubed is 4 times 4 times 4. And another way to write 4 squared is 4 times 4. So Miss Solomon, are you seeing some simplifying we can do?
Yes, we can cross out 2 of the 4's in the numerator with 2 of the 4's in the denominator.
Perfect. So when we see something the same in the numerator and the denominator, we know we can cancel them out. And what we're left with is just 1 4. And another way of writing just 1 4 would be 4 to the 1st power. So are you seeing a shortcut here? We took 4 cubed divided by 4 squared and we end up with 4 to the 1st.
Yep, we just kept the base the same and subtracted the exponents.
So our shortcut rule is, just like she said, keep the base the same and subtract the exponents. Now you have to remember, when we subtract the exponents, it's the numerator minus the denominator. All right, our next rule that we are going to look at is called power to a power. So what is happening when we have a raised to m and then raised to n? So let's plug in some numbers so we know exactly why our shortcut works. So if we have 4 squared raised to the 3rd power. Well, let's go back and think about what Miss Solomon had been thinking about before. So what's this 3 really represent, Miss Solomon?
Repeated multiplication.
Repeated multiplication of what?
What is the base?
The base. So in this case, the base of this exponent, the cube, the base is really this entire thing inside the parentheses. So it's repeated multiplication of 4 squared. So now I'm seeing something familiar from the beginning of this video. I see multiplication and I have the same base. What do we know about multiplying with the same base?
We can just add the exponents.
So this is really the same thing as 4 to the 2 plus 2 plus 2, which gives us 4 to the 6th. So if we think about our original problem of 4 squared raised to the 3rd power, and we now know the answer is 4 to the 6th, are you seeing a shortcut?
Yep, you can just multiply the exponents.
Multiply the exponents. So our shortcut, when we have a to the m raised to the n, is to keep our base the same and multiply the exponents. So our next rule combines actually a couple of our other rules. So what if we had a product, so we're multiplying a product raised to a power. And we have a shortcut for this, but it's kind of hard to see when we're looking at letters, so let's look at an example with numbers instead. So let's look at an example with numbers. So what if we had 4 squared times 2 to the 5th, all raised to the 3rd power. So on the inside of parentheses, I have multiplication. I have a product, and I'm raising it to a power. So thinking back to order of operations, it tells me to start with parentheses. So I'm going to look in the parentheses. I see multiplication. That means I can add the exponents. Miss Solomon, does that sound right?
No, because the bases aren't the same.
Our bases aren't the same, so we actually can't use that rule where we multiply and add the exponent. So I can't start inside the parentheses. That means I need to start with the exponent. And once again, this exponent means
Repeated multiplication of the base.
repeated multiplication of the base. And in this case, what is the base of that 3?
4 to the 2nd power times 2 to the 5th power.
So that entire thing is the base, and I'm multiplying by itself 3 times. Now, this to me still doesn't look helpful. But I know that in between all of these parentheses is really just multiplication. And I know I have some rules about multiplication, so I'm actually just going to drop all of those parentheses. And let's look at this without the parentheses. What are you seeing here, Miss Salmon?
There are 3 bases that are 4 and 3 bases that are 2.
So we're seeing that we have some bases the same here. So let's write those together. And maybe this will help us with our simplifying. So now that I've moved things around so things with the same base are written together, are you noticing anything we can do?
Oh yeah, we can just use the rule we learned: when the bases are the same, add the exponents.
Bases are the same with multiplication, so 4 squared times 4 squared times 4 squared is really 4 to the 6th times 2 to the 5th times 2 to the 5th times 2 to the 5th is actually 2 to the 5 plus 5 plus 5, which is 15. So if we go back, our original problem was 4 squared times 2 to the 5th raised to the 3rd power. And we found out that that answer is actually 4 to the 6th times 2 to the 15th. And we did out all this math to get to that final answer. But like I said, our laws of exponents are shortcuts. So if we look at the question and we look at the answer, Miss Solomon, are you seeing a shortcut?
Oh yeah, we can just multiply the exponents for each of the bases.
Perfect. 4 to the 2 times 3 times 2 to the 5 times 3. If we think about that math, we get 4 to the 2 times 3 is 6, and 2 to the 5 times 3 is 15. So our shortcut when we have a product raised to a power is to multiply our exponents. And you need to make sure you're multiplying exponents, not bases. So it's a to the r times c. See how I'm multiplying the exponents? Times m to the s times c. So the last rule that we are going to look at in our review of the laws of exponents is, what about when we raise something to the 0th power? And a lot of teachers teach this rule a different way. We're just going to show you one way to think about why the answer a to the 0 is 1. Anything raised to the 0 power is 1. So if we think about some of our old rules, if I had 4 divided by 4, that's something divided by itself. We know that to be 1. 4 divided by itself is just 1. And if we continue to think about it as something divided by itself, well, 4 to the 5th divided by 4 to the 5th, that's something divided by itself. That answer should be 1. But Miss Solomon, if we think about our laws of exponents we've already looked at, what do we know we would do when we divide?
When the bases are the same, we can subtract the exponents.
And what power do we end up getting?
0.
So these two things must be equal since we started from the same spot. So that's just one way of looking at it, of when we raise something to the 0 power, the answer should be 1.